All right, thank you. I'm really curious, does anyone know what this is? It was a game back in the 90s in the US that was really popular, but I don't think it translates over here. Anyone familiar with Carmen's? Okay, cool. This actually recently came back out on Netflix. I'm really excited for my kids. So a little bit about me. I run Citus Cloud, work at Citus Data, which was acquired by Microsoft about 4 months ago now. So now work at Microsoft as a product manager on their database side of things. Previously, I built and ran Heroku Postgres for about 5.5 years. So I had a team of about 8 people that we ran and managed around 1.5 million Postgres databases. So at that scale, a 1 in a million problem was literally once a day. I also curate Postgres Weekly. Anyone here subscribe to Postgres Weekly at all? Okay, a few hands. If you like Postgres, it's a highly curated weekly newsletter that comes out, more focused on like app dev and cool things you can do with Postgres, as well as what's coming in new releases. Less so from like a DBA perspective. So if you want kind of like what happened this week in the Postgres community, give it a look. So first off, what are extensions? Even if you aren't familiar with them, you've probably used them in some way. So Postgres is really, really unique as a database, and then it has these low-level extension hooks that can allow you to completely change the behavior of what's going on within Postgres. They can be written in C to be extremely performant, just like Postgres, or in higher level languages. So you can write them in pure SQL. You can do a lot of things with them. You can create new functionality, new data types, new indexes, all sorts of things to completely change what Postgres is able to do. Now, to me, this is really interesting and notable because now Postgres has a 1-year kind of release cycle. There's a really, really high bar for what gets into the core of Postgres. But how do we experiment? How do we kind of move faster? How do we try things? Extensions are basically that framework. So we can take Postgres, adapt it, change it, test things without having that high bar. And what we'll see is a lot of things that are kind of working outside as extensions in time become directly within Postgres, or they can just stay as extensions. So Postgres itself ships with a few native ones. These are known as contrib extensions. Other ones have to be built and installed from source or from packages. If you're on someone like a Microsoft Azure or Amazon RDS, there's a list of ones already provided for you. You can't kind of bring your own typically. A few of the contrib examples. PG stat statements, I'm going to walk through that one in more detail. HStore was a key value store, kind of one of the first NoSQL data types directly within Postgres. It's really nice. CI text is case insensitive text. I actually see a lot of people that come over from MySQL over to Postgres because it doesn't support case sensitivity. And if their application accidentally expected that, I think that's kind of an anti-feature. But for whatever reason, they expected case insensitivity to be there. It's a great tool. A few of the non-contrib ones. We're going to go through some of these in more detail. PostGIS, we'll give a really high-level one of it. Citus, which we'll drill into. Zombo's a fun one, which allows you to have Elasticsearch indexed. So send your data from within Postgres over to Elasticsearch. Then when you query it, it can automatically use Elasticsearch indexes from directly within Postgres. So you get a lot of that full text search indexing while having Postgres as your system of record relational store. And the rest of these I think we'll get into in a little more detail. And so apologies if I'm going a little fast. I think I've got another 70 slides to get through in 30 minutes. Consider this a tour of extensions. I want this to be like the primer, the 101. Maybe you've used all of these and this is kind of not news. Hopefully there's something new in here for everyone that it kind of sets off a flag saying, if this is interesting, go dig deeper, give it a try, learn more. So the first one, PG stat statements. To me, this is the most useful extension that exists within Postgres. Has anyone here not used Postgres PG stat statements? Okay, a couple of hands there. It's okay. So it's incredibly useful. What it does is record every query that comes into the database, essentially parameterizes that and stores it. So you can say like, if you have something like select star from users where email equals craig@citusdata.com. It's going to replace that craig@citusdata.com with a question mark and save that. So each time I rerun that query for another user, it's going to record how many times it ran, how long it took, and a whole bunch of other data. So it's going to show all this sort of stuff that I kind of understand some of it about how many shared blocks are written, how many things were dirtied, that sort of thing. You don't have to understand all of this to get some really useful insights from this. You can run a really, really simple query that's going to give you, and you can probably guess right here, the total time a query has consumed against my system and the average amount of time. When I come to a new database and PG_stat statements is enabled, this is one of the first things I'm going to look at is like, how is performance? Are queries executing about where I expect them to? What things are, an n+1 loop in my application that I can refactor them? And it's going to give a really simple kind of look like this. For me, a rough kind of set of guidelines I'm going to have is most really quick transactional queries. I'm going to target about 1 millisecond or so, give or take. Longer running queries that are doing some aggregation or giving back hundreds, thousands of rows, I might expect to be closer to the 100 milliseconds. With this, I can actually see right here that second query, whatever that is, on average, it's spending 80 milliseconds. So I can actually optimize this, get it down to not 10 milliseconds, but 1, and give that query kind of 2 orders of magnitude performance back. So completely new database, not knowing anything about the application, I can get this really nice high-level view. Super, super useful. I'll get to Citus later, but one small plug that we took PG_stat statements and extended it with Citus stat statements. So a common use case for Citus is multi-tenant applications where you have something like by tenant or by customer ID. And what we found was PG_stat statements was replacing this. And a common question for a multi-tenant app is which of my customers is the most expensive? Which one is doing the most writes, the most reads, that sort of thing. And so here we actually preserve that tenant ID. So we say, where customer ID equals 1, 2, 3, we don't strip that away. So you can see which customers are costing you the most money, using the most resources. You can use that to charge them differently or figure out if you want to go and isolate them to their own hardware, that sort of thing. So kind of a addition of PG_stat statements where we're preserving some data that we were previously losing. All right, PostGIS. So PostGIS is pretty well regarded as the world's most advanced geospatial open source database. The really only competitor to it in the market is like a proprietary product like Esri. PostGIS deserves its own full-length talk. It's very interesting that there's the Postgres kind of core developers. There's also the set of PostGIS core developers. And they move at their own cadence, their own release process. They have their own complete kind of separate community or at different conferences. So a really rich ecosystem around it. With PostGIS, what you're going to get is not just kind of one piece. Like some extensions are, here's a new data type or here's a new index. With PostGIS, you're getting kind of everything that it could give you in one box. So you're getting new spatial data types like points and polygons and lines. You're getting new indexes that work on those data types, like just indexes. So you can index and query really efficiently into shapes. And new functions. So like new functions that you can operate on all these things. A kind of really basic example, if I've got like points that are latitude and longitude and I want to compute the distance between them. Or if I want to compute, if I got a polygon and show me how many kind of restaurants are within this polygon. If you have like a just index on your data there, it's automatically going to index that, be really, really efficient. Again, it deserves its own complete talk. So if you're using it, definitely kind of doing anything geospatial, dig in and give it a look. It also has other extensions that build on it. So it is probably the most advanced and complex extension that exists. There's other ones that connect to things like LiDAR data or for routing and mapping, like how do you find a certain route based on roads and otherwise. And then the geospatial community, as I mentioned, is its own kind of thing. There's certain standard data types which you can connect to and query as well. So really, really rich. If you're doing anything geospatial, give it a look. All right, HyperLogLog. This is one of my favorite ones just to say because it sounds cool. HyperLogLog was actually a paper about, I think it was about 13 years ago out of Google. If you read the paper, it has things that look like this, like k-minimum value, bit of observable patterns, stochastic harmonic averaging. Does everyone know exactly what all these things are? Cool, because I don't. Like I read the paper and I'm like, this is great. There's math I can't follow. To dumb it down really, really simply, it's probabilistic uniques with a really small footprint. So, or another way, just close enough uniques. So if I've got something like Google Analytics and I want to know how many unique visitors I saw yesterday, they're not giving you an exact account. That is an approximation algorithm that is close enough. The amount of data they see, counting uniques would be absolutely horrific. You'd be waiting tomorrow for your report from today. So how does it work? With it, you would go in here and say create extension HLL. HLL is short for HyperLogLog. And then you're going to have this new data type. I'm going to call it, my data set, and I'm going to call it HLL. Now, it works a little differently than most other data types. You don't just insert into it. Because it's this compressed format stored directly in one field, you're going to have to do some aggregation on data as it comes in. So what I'm going to do is I get these new functions and operators and say I'm going to hash this user ID 1, 2, 3, 4, 5 as it comes in and add them to this set. So what I might do is create uniques for Monday, uniques for Tuesday. Every time I see a new user from my raw data, I'm going to say hash this user and then add it to the set. So I'm going to come today, I see someone else comes in, so now I have 2 uniques. As that user comes back in, it's not going to keep incrementing that. So it's not just a counter. It's doing all that crazy math under the covers to say approximately I'm sampling some zeros in front of this number based on this hash, padding it into this bucket. So yeah, here I'm going to go ahead and say let me create a unique set of dates and let me store all my unique users. So here I'm going to have a value for every single day of the year. Which is great. So Monday I see 5 uniques, Tuesday I see 10 uniques. So in the real world, you're probably getting a bunch of raw data, capturing this, like you've got a page views table, you're capturing this, and then maybe every 5 minutes you roll that up into this new bucket. So every 5 minutes I'm rolling this up and storing the data for today until I get to tomorrow, and then I'm going to go to tomorrow's bucket. If you query this, everyone can parse that, right? You get something completely unintelligible. But there's a lot of really, really powerful data in here. So just like we had some new operators to insert data, we have new operators to read the data as well. So here what I'm going to do is do this union ag. And this is where the power of HyperLogLog really comes in. So if I had 5 uniques on Monday, 10 uniques on Tuesday, but I want to know how many uniques did I have on Monday and Tuesday, I'm going to be able to aggregate those 2 values, that 5 and 10, and it's going to come back with something like 13. So I can find the union, I can find the intersection, I can find the exclusion, all these things in a really interesting way. So I can save uniques on a given day, combine them to get uniques per month, uniques per year, etc. So a few best practices around it. You don't want to always insert, like you want to maybe insert the first time. After that, you want to update your HLL. Otherwise, you're going to replace what was there. This is really commonly done in batch. So like I said, you're taking in a lot of raw event data, rolling it up on a 5-minute, hourly kind of increment into this data type. And you probably do want to tweak the config. So there's a lot of different configs and flags that you can set on how accurate is it. Like, do you want it to be really, really accurate, but have a bigger footprint on disk? Or do you want it to be 99% accurate, but have a really, really small footprint on disk? So there's a number of things based on your data. You can read through the docs. They're pretty good about how you want to tune things. I would say tune it. Don't just accept the default. So the question is this better than just doing a distinct count? If you've got really small data, a distinct count works fine. If you've got a lot of data, here you can have something that's about 1,000 or so bytes. And you can estimate about tens of billions of uniques with just a few % error. So for something like Google Analytics, if you're seeing 10 billion uniques and I've got a % or so error, I'm pretty okay with that for that kind of storage and compression overall. All right, so some of the common use cases for it. Really, it's around kind of ad networks, web analytics, things that are close enough. I wouldn't use this for banking because people kind of aren't too happy when you estimate with their money. But you can kind of see the use cases. Anything that's analytics, that it's close enough, and really, really large data set. If you've got a small data set, it doesn't really matter. So TopN is another approximation one, and I'm really excited to see more and more kind of approximation algorithms come into Postgres as we deal with larger data sets. So as Postgres is getting used for more and more, data is growing more and more, how do we handle things like a median or something like that? So TopN, also often referred to as TopK in something like Elasticsearch, is give me the top, say, 10 pages in terms of page views for the past week. Or top list of people that I saw that bought the most amount of stuff. So it's in many ways modeled really, really similar to HyperLogLog. So instead of there is one difference though. So instead of having a new data type right there, you're just going to put this into a JSON-B, and then you're going to have all the same operators. So when you insert into it, you're going to use the same kind of aggregator, TopN, add aggregate right there, and put this directly into that JSON field. Now the nice part about this, everyone remembers how the HLL looked when we queried it, right? Super intelligible. Here we actually get something we can use. So this is really nice. Like in a JSON field, we can see the raw data if we want to just look at it, parse it, that sort of thing. But then if we want to query it, we actually can use that aggregator again, TopN union ag, that's going to union across these days across, and this is the GitHub events public data set. So how many people, I believe this is how many people created a GitHub repository or pushed to a GitHub repository. Here we see a bunch of kind of API things, things that are automated. So if I want to find my most active GitHub users with an approximate list, really, really nice. So yeah, if you're dealing with large data sets, want to have like a top 10 kind of page views, users, like that kind of dashboard. We see this really commonly in any sort of dashboarding application. TopN can be really, really nice without having to do the full count. Timescale. So another thing I'm pretty excited about is that we're seeing entire companies pop up around Postgres extensions and the ecosystem. So we've had a lot of Postgres consulting companies for a long time and a great community around it. Some of those have authored extensions themselves. A number have. Citus itself was founded about 8 years ago. As I mentioned, recently acquired by Microsoft, but a full kind of company devoted to scaling out Postgres. We've got another one, Timescale, that is focused on time series as a pure extension. So it's nice to see that Postgres is so big that we can support entire companies around this really specific use case and expanding Postgres and what it's able to do. So Timescale, per their docs, is really useful if you have time series data. But I'll caveat that just because you have any time series data, like most things have like a created at timestamp, it doesn't necessarily mean you have time series data. There's a couple of things that make you want to go down a partitioning path. So one, the obvious, records always have a timestamp no matter what. The other big one is it's really commonly append only. You're not going in there and updating any of your data. It's just new data comes in and it gets appended. The other piece is, I'd say, really key also is that you're often looking at recent data. You're not querying the whole data set. If you're always querying the whole data set, you're losing a lot of the advantage of what time series will give you. Part of the benefit of a time series database is you can easily drop old data. So you've got new data coming in, you're doing roll-ups, so you've got a different granularity of your historic reporting than you do your recent reporting. So if you're not kind of dropping old data and typically querying the recent data, then you may not actually want a time series database. All right, so before we saw, we had a new data type with HyperLogLog and TopN. Here what we've got is a new set of kind of tables under the covers. So Timescale is hooking into the executors and changing like how Postgres executes certain things. Here I've got a pretty standard rides table, which is like taxi ride data. Where do they pick up from? Where do they drop off at? What was the time? What was the fare? All that sort of thing. So this is just a standard Postgres table. Once you install Timescale, you're going to get this new operator, create hypertable. Hypertable is their notion of like what is a time series table that kind of spans multiple time periods. Under the covers, this is going to go and create multiple different tables. It's going to create like a rides table for every 5-minute bucket of data that it sees. And it's going to do that based on the pickup date time in this case. Now querying it, I'm just going to query it pretty much like normal in this case. So here I'm saying give me the average pickup time based on day with greater than one passenger. So this is just standard SQL, but under the covers, it's rewriting this to target those hypertables it created under the covers. You also have some new operators there. Like I can automatically create nice kind of time buckets of 5 minutes, so I don't have to do the date trunk math. It's basically going to take care of all the new partition creation, take care of kind of indexing the right places, a lot of things with that aren't in the kind of native Postgres time partitioning. Now, Postgres got native time partitioning 2-3 years ago, and I say it's now getting to the point where it's pretty good. I think I tell a lot of people this: anytime the first new feature comes out in Postgres, like the first time it's there, probably wait 1 year to use it. Like there's rough edges, it's not perfect. There are probably exceptions to that. At the same time, I'm super excited any new feature comes out, such as like the pluggable storage stuff. Really excited. I probably won't use it in production for another year or so. If you want to use the built-in native time partitioning, there's another option. So Timescale does its own thing. If you're using the native time partitioning, I'd say it's probably one release away from being completely self-sufficient. If you want to use it, I would recommend pgpartman. So pgpartman smooths out a lot of the rough edges with the native time partitioning. So it's another time partitioning extension, but it builds on the native stuff. So it doesn't go and recreate its own thing. Here we're going to come in and do standard Postgres time partitioning with it. We're going to say create my table and partition by some range. In this case, I'm going to do the created at of the GitHub events. To enable pgpartman, I'm going to come in here and say create my partition. I'm going to specify to use the native partitioning, and in this case, I'm going to do it hourly. I could do this 5 minutes, whatever makes sense. One thing you're going to want to do is update your config right away to keep creating partitions. Unless you've got a really, really fixed data set, you want to go ahead and do this right away. I think the number one thing I've seen with anyone that does time-based partitioning is they say, I'm going to create 1,000 partitions. That's enough for forever. My application is going to be fine. And in 1,000 weeks from now, something's broken. You're not around to maintain it. You've moved on to 2 new jobs. And they're still like tracking you down because you were in the commit log somewhere asking you to fix this thing that you wrote 1,000 weeks ago. So automating your partition creation, really, really key. So under the covers, what this is going to do, this looks like it's actually 5-minute buckets here. It's going to create a new partition for every 5 minutes of data that comes in. pgpartman stores its config just in a table. I kind of like this. It's pretty handy and simple. I don't have to go load a config file. I can just run a query to update things. You're going to want to change a few things in here, like updating partitions in the future. You can change what the interval is. You can change the retention. How long do you want to keep partitions? So that pgpartman in the background will automatically go and drop old partitions. So if you're working with time series, you should be dropping data over a month, a year, whatever makes sense for your application. pgpartman is automatically going to go and drop those old ones for you. It'll also go ahead and create certain ones ahead of time. So it says pre-make right there 4. Well, as I see data right now, I want to create 4 buckets into the future so that as new data comes in, I'm not having to run that create table to create indexes, that sort of thing. So I'm doing that overhead ahead of time. So why not native partitioning? To me, I would actually say Partman is native. It takes all the native stuff, extends it, gives you kind of some nice helper utilities, some automation around creating new partitions and that sort of thing. So it smooths out a lot of those rough edges. And I expect over time more and more of pgpartman just to come directly into core, so you don't need an external extension. All right, Citus. So Citus is an interesting one. I'm biased. I've worked on it for a few years. But it takes Postgres and transforms it into a distributed horizontally scalable system. So still transactional database, just scaled out across multiple nodes. to your application, it still looks like a single node database. It doesn't know things are sharded. So you don't have to think about all that application complexity. What is sharding? Per Wikipedia, it's just the notion of splitting your database into smaller parts. I see a lot of people do this with like a one database per customer. So it's like, oh, every time a new customer comes in, I'm going to create a new database. This works if you have 10 or 100 customers. When you have 1,000 and 10,000 customers, now things like schema migrations are really fun and complicated. When it worked for 900 users, but 100 fail. And how do you go fix that? So one notion, I think a lot of people get confused on the basics of sharding right away. So there's nodes and there's shards. Nodes are composed of shards. So here, if I'm sharding my database, what I've got actually are 16 different shards spread across 2 nodes. Up front, I'm going to go ahead and create a really large number of shards. The reason, because if I add, go from 2 nodes to 4 nodes, what I want to do is just move a table around. I don't want to have to go and invasively split out a table. That's a much heavier weight operation than just spinning up logical replication and copying it from one node to the other. So what am I going to do? I'm going to hash based on some ID as it comes in. The Postgres internal hashing can work just fine. You're going to define a larger number of shards up front. So 2 is probably too small. It means it's going to be really hard to scale past 2 nodes. 2 million is probably overkill. I don't know that many people in the world running 2 million physical Postgres instances. I like orders of 2, but you don't have to. 32, 128 are some nice numbers. And then you're not just going to route the values. So the other thing I often see is people say, hey, user 1 through 10 are going to go in this bucket. User 2 through 20 are going to go to this bucket. Instead, what we're going to do is create a range of all the hash values. So as user 1 through 10 come in, we're going to take the hash value of each user and then figure out where that bucket is. This is going to create a nice data distribution automatically. What you'll often find is user 1 through 10 are your oldest, most important customers with your largest data. So if you put them all together to start with, well, now you've got a really, really hot shard where others are kind of empty because they're the newest customers. All right, so let's see how it actually works. So very similar to Timescale, I'm actually just going to create some standard Postgres tables. Here I'm going to create a GitHub events table and a GitHub users table. What I'm going to then do is have this new function called create distributed table. I'm going to feed in the table name, and I'm going to feed in what I'm going to shard my data by. In this case, I'm going to do it both by user ID. This is really interesting that I'm sharding both events and users by user ID. So now like user 1 is always together on the same node. So when I do a join, I don't have to send data over the wire. I can push this down directly to the node that it's on and do a local join there. So if we do something like a count star, right? My data is spread across different nodes, different shards. How does this work? Here, essentially what we're going to do is use one executor that splits this up and does map reduce on data. So to get a sum across all of my events, I'm going to do a count, and then I'm just going to sum that up. Here you can see this is like one of, let's see, task 1 of 32 right there. So it's running this 32 times against 32 different shards. You can also do things like averages or aggregation. This makes other data types like HyperLogLog and TopN really interesting because those are composable across distributed systems. If I'm doing something that's a really quick kind of single lookup, it's going to use a different executor. So here I'm not going to fan this out to every single node. I'm going to say because I have user ID 123, I know that lives on shard 1. I'm going to rewrite this, send this down to that node, get that data, and return right away. And I had to throw this in here just because this is like the one little piece of UI that we have within the product. We're very much database engineers, so like UIs are not our specialty, but it's kind of the UI that shows how it works in action. This reminds me of the Windows 95 disk defrag. Does everyone remember that? Like, I didn't know if it was doing something, but I felt really like powerful. And you can basically see, like, I've got physical tables that I'm moving from one node to the other with logical replication there. So everything's fully online. I don't have to think about it as I'm scaling out from like 2 nodes to 4 nodes. All right, foreign data wrappers. They're kind of a class of their own. Technically, they are extensions, but they're like a whole other class. I absolutely love them. They allow you to connect from within Postgres to something else. So there are foreign data wrappers for about everything you can imagine, like Redis, Mongo. CStore is a columnar store. To use them, you'll come in here and create a foreign server. Then you'll create the table, which is the mapping to it. So here I'm creating in my foreign server that points to my Redis server. In this case, maybe I'm tracking visits in Redis, and I want to see how many people visited this site 10 times but never bought from my shopping cart. Now, I would say be careful with some of these. So here I've got this foreign table, Redis, and I've got user ID like 40 and the number of kind of values there. Some foreign data wrappers are really, really effective. Like the Postgres one pushes down predicates and filters. The Redis one brings back the entire data set. So I wouldn't actually put this in like a production application, but for kind of like offline ETL data reporting, really, really useful. So here I can do something like join, where I've got users that I've seen more than 40 times, and maybe they've not bought something that I want to reach out and say, hey, here's a 10% off coupon, that sort of thing. All right, that was a lot. Apologies for going really fast. In conclusion, to me, Postgres is really more than Postgres. 10 years ago, it was a relational database. Then we got full text search and geospatial support and JSON. But it's really more of a platform, and I think extensions are a huge kind of area we're going to see a lot of growth, not just right now, but over the next 10, 20 years. The fact that we can innovate and make it do things it couldn't otherwise without having to wait for a core release. Like core needs that bar to be really, really high and stable. But the extension frameworks and kind of APIs there allow us to do something that maybe otherwise we would never think of. There's like a dev null foreign data wrapper that just writes data to nowhere. So we can have a really great performance benchmark that, just for fun. There's a few honorable mentions. I would check these out. Madlib is like data science directly in Postgres. PG cron, if you got a cron job, why run it outside Postgres? Run it in your database if you're doing something every day or week. If there's something you kind of want to do and Postgres doesn't have it in there, search for the extension. Like it's probably there. And if it's not, consider writing one. And that's it. Thank you.
Thank you, Greg. Questions? Any questions?
What's Zombo DB that you mentioned?
So Zombo, as you write data into Postgres, will send it over to Elasticsearch and maintain indexes on full text search and Elasticsearch. Then when you query directly within Postgres, it can actually use the Elasticsearch index for text search.
It's kind of a foreign data wrapper, but more stuff.
Yes, kind of foreign. Like you're actually querying directly within against your Postgres table using like a new kind of operator to say, oh, now use this index over here. So it's sort of a foreign data wrapper. It's not actually querying the data. It's only using the index. And then as data is indexed, it's inserted into the Postgres table, it's automatically sent over and kept in sync. So it's not like I had to insert it via a foreign data wrapper.
Okay, that's cool.
Yeah.
How is the update progress when you have extensions?
So-
Any change releases of Postgres checks?
Yeah, so extensions have their own kind of versions. The extension version tends to work fine with new Postgres versions. Sometimes that's not the case. I would say that's rare. So as you upgrade Postgres, you're generally fine. An exception would be like Postgres keeps getting better with its own time partitioning. Well, you had to go from PG Partman 3 to 4 if you went from Postgres 10 to 11 because of how some of those things were changed. In general, though, you can kind of manage them independent in most cases. But I'd say like as you're using an extension, you do want to pay some attention to that. All right, thank you.
Thank you.